Hey everyone, and welcome. Artificial intelligence, AI. It's a term that's absolutely everywhere. But what is it, really? Let's forget the hype and the crazy headlines for a minute. In this explainer, we're going to pull back the curtain and break down how AI actually works, right from the ground up. So, where do we even begin? Okay, first things first, we've got to clear up a huge misconception. When you hear AI, your mind probably jumps to sci-fi movies, right? Thinking feeling robots. That's what we call artificial general intelligence, or AGI. It's this idea of an AI that could do any intellectual task a human can. But here's the thing, it doesn't exist yet. The AI that we use every single day is what's known as narrow AI, and it's designed to do one specific job, whether that's understanding your voice, like Siri, catching spam in your email, or figuring out exactly which movie you're going to want to watch next. It's an incredibly powerful tool, not a thinking, feeling being. Okay, so if it's just a tool, you might be wondering, well, how's that any different from a regular computer program? And that is a great question. Think of it like this. Traditional programming is like giving a computer a super detailed recipe. You write out every single step, line by line, and the computer follows those instructions perfectly. But with AI, you don't give it the recipe. Instead, you show it thousands of pictures of the finished meal and basically teach it to figure out the patterns for itself. You see, it learns from data instead of being stuck with fixed instructions. And to really get how it does that, we need to look at its core ingredients. To really understand how that whole learning process works, we need to break it down into the three core ingredients that make up pretty much any AI system. These are the fundamental building blocks for everything else we're about to cover. All right, first up, we've got the model. After an AI has gone through all that data and done its learning, the final result is the model. It's basically a super complex mathematical structure that represents the problem it's trying to solve. You can totally think of it as the specialized brain that the AI has built for one and only one specific task, like spotting cats in photos or predicting what a house might sell for. So how does the AI actually build that brain? Well, that's where the algorithm comes in. The algorithm is the process, this set of rules that guides the learning. So if the model is the brain, the algorithm is kind of like the teacher. It's the specific method the computer uses to comb through all the data and build that model in the smartest way possible. And finally, we have what is, without a doubt, the most important ingredient of all, training data. This is the fuel for the whole engine. It's all the information, the pictures, the text, the sales numbers, you name it, that we feed into the algorithm to teach the model. And listen, this part is so important. An AI model is only as good as the data you train it on. If you put garbage data in, you're going to get garbage results out. Simple as that. So you take those three things, data, algorithm, and model, and they all fit together in what we call the AI pipeline. It all starts with collecting the data. Then, and this is a huge step, you have to clean that data up. Only then can you actually start training the model. After that, you've got to evaluate it, test it to see how well it works, before you finally deploy it into a real-world system. It's a whole journey, from just raw information to an intelligent action. So we've got our ingredients, a model, an algorithm, and data. But how does the learning part actually happen? Well, it turns out there isn't just one way to do it. Let's dive into the three main strategies that machines use to learn. So, AI basically learns in three main ways. First, you've got supervised learning. This is just like studying with flashcards. The AI gets a bunch of data that's already labeled with the right answer, like this image is a cat, this one is a dog. Then there's unsupervised learning. In this case, the data has no labels. It's like someone hands you a giant mixed-up bag of Legos and says, sort these. You have to find the patterns and group them yourself. And third, we have reinforcement learning, which is all about trial and error. Just think of training a dog with treats. The AI tries an action, and if it's a good one, it gets a reward. If it's a bad one, it gets a penalty. Over time, it learns the best way to get the most rewards. Now, those three methods are really powerful, for sure. But for the really complicated stuff, like understanding human language or recognizing your face, AI needs something even more sophisticated. And that approach is called deep learning, and it's powered by something modeled directly on our own brains, neural networks. So how does one of these things actually work? Well, it's all about layers. A neural network has layers of tiny nodes. The first is the input layer, which acts like our senses. It just takes in the raw data, like all the pixels in a photo. That data then gets passed through one or more hidden layers, and this is where the real thinking happens. And finally, it all comes out the other side, at the output layer, which spits out the final decision, like cat or not a cat. But how does the network actually learn inside those hidden layers? The secret sauce is a concept called weights. You can picture weights as millions of tiny little knobs. As the AI is training,
The algorithm is constantly tuning these knobs, turning them up or down. This changes how important each connection is, all in an effort to get closer and closer to the right answer. This tuning of weights, that is the essence of how a neural network learns.
I know. All of this might sound a little abstract. Models, algorithms, neural networks. But here's the cool part. You are already using these exact concepts every single day, probably without even realizing it. Let's connect the dots and see where this stuff shows up in your life. When you ask Siri for the weather, that's a deep learning model for natural language processing, figuring out what you actually mean. When Netflix recommends that show you end up binge watching, that's a supervised learning model that was trained on your viewing history. And yeah, that face unlock on your phone, that's a deep learning model doing its thing. Even in business, tools like Salesforce Einstein use AI to predict which sales leads are going to turn into customers. This isn't science fiction, people, it's already here.
But here's the thing. Because these systems are trained on data that comes from our world, they can also learn our flaws. And this brings us to one of the most critical topics in AI today, the challenges and the ethical questions we absolutely have to deal with. There's a catch, though. Since an AI learns from the data we give it, it can absorb and even amplify our real-world biases. And this leads to a really important question. What happens when the AI gets it wrong and makes a decision that's totally unfair?
This is a classic and very real example of the problem. Imagine you train an AI model to screen resumes, but you train it on years of data from a company that mostly hired men. Well, the model is going to learn that male-sounding resumes are better. It'll then start automatically filtering out qualified female applicants, not because it's evil, but because that's the biased pattern it learned from the data we fed it.
Now, the good news is, this is a solvable problem. It's not hopeless. We can fight this bias by being really careful to use diverse and representative data for training. We can constantly audit our models to check for unfair results, and we can clean our data to remove that skewed information before we even start. And maybe most importantly, for any really big decision, we have to keep a human in the loop. To help with all this, there's a new field popping up called explainable AI, or XAI. And the whole goal is to open up that AI black box. Instead of an AI just giving you an answer, XAI helps it show its work. So if an AI system denies someone a loan, it won't just say no, it'll explain why, pointing to things like a low credit score or too much debt. That kind of transparency is absolutely essential for building trust and holding these systems accountable. And that, really, brings us to the final, most important point. We've seen that AI is an incredible tool built from data, algorithms, and models. It's not magic, it's just math and engineering. But as we build these systems to be more and more powerful, the most important part of the equation isn't the technology, it's us. AI can give us some unbelievable answers, but it's our job to make sure we're asking the right and the most responsible questions.